Welcome to the bug collecting track. You are here to hear Raj and Jeremy talk about network streaming and debugging with Mallory. So let's give them a hand.
All right, well, good afternoon, everyone. I hope everyone had a good lunch, and I'd like to thank you guys for attending our network debugging with Mallory. So we're just going to do some quick introductions so we can kind of get to you guys to get to know us a little bit. After that, we're going to talk a little bit about what we do over at Intrepidus Group and how specifically those interactions led to help us figure out, hey, we need to develop this new tool called Mallory. So we're going to explain why we believe Mallory needs to exist, and then after we do that, we're going to show you how we put it together, talk about a little bit the architecture of Mallory, how it works, and how you guys can help code and develop on it and try to make it a little better. And then after that, we'll get into some demos to show off a little bit about how Mallory really can help pen testers doing these one-off TCP-based or UDP-based network application assessments. So who exactly are we?
I'm Jeremy Allen. I'm a principal consultant at Intrepidus Group. I've been doing information security consulting for about 4.5 years now, and prior to that, I developed software for a bit over 10 years, so I've been in the information technology industry for a while. I teach secure coding, I write a lot of Python code, and I try to break stuff and hopefully share with others about how I broke things. So that's what I do.
My name is Raj. I guess you can call me the youngin of the group. I graduated about 1.5 years ago, and I was pretty fortunate to get picked up by the Intrepidus Group and have a lot of the guys help me out and mentor me and get into security a little bit more. I deal with a lot of mobile application security right now, specifically dealing with mobile apps on iPhones, Androids, and such. And I feel pretty lucky that I get to deal with that kind of stuff because according to my colleagues, a lot of the bugs that I'm finding are these legacy bugs that used to be in like web applications 5-10 years ago, but they're popping up again. So I feel a little lucky about that. I get to learn from the bottom up still. This is my first Black Hat, so I'm definitely pretty excited to be presenting to you guys right now. So what exactly do we do? Before we get into that, we just want to whet the appetite a little bit and just show with a quintessential proxying example that people have seen all the time done in very different ways, what Mallory can do and how it can do it very easily. I'm going to bring it up really quick, and Jeremy's just going to explain what I'm doing.
All right, so this is just a pretty simple example of flipping images around and inverting images in on a kind of local test network we have. This is all running internal. We didn't want to try and do internet for live demo because we feared it would explode. But basically, we have a WordPress site installed, and when you look at images, they'll be flipped upside down, and the colors will be reversed. And you've probably seen that done a number of different places in a number of different ways. But the point was that this took us about 15 to 20 lines of code, and it's pretty simple and straightforward. So that's kind of was our goal, is to make man-in-the-middle tasks easy for our application testing. So I know it's not that exciting, but we did a lot of that kind of stuff inside of Mallory that is a lot more exciting.
Yeah, and the cool thing to note is that it is being done within the stream. It's not like it's taking the picture, putting it somewhere, changing the picture, changing the HTML to point to new pictures, actually doing that manipulation within the TCP stream itself. So so a little bit of introduction on why we, what do we do and how does that lead to us wanting Mallory? Well, we do a lot of mobile application assessments. A lot of these assessments, they happen on brew devices all the way up to Android devices, from the very simple to the very complex mobile application operating systems. These applications, they obviously have network streams that we're used to, HTTP and whatnot, but sometimes they don't, and we'll get into that a little later. A lot of times we are dealing with embedded devices or applications on the embedded devices themselves. Again, these applications on these embedded devices, they're not often given us from a white hat point of view. We need to do a black box assessment. We won't have access to the code. We're not going to have access to the development environment. So we need to figure out a way to how are we going to assess this application if we can't, get that code and put it back into our computer and use our regular tools. We're going to need to get at the stream itself and start our assessment process dynamically within that stream. So that kind of helps set the tone that if you're doing this application assessment on, let's say, this web application on an embedded device, you need to be familiar with the network side of the house as well, and you need to figure out how am I going to get at that stream and do my manipulations. We do all the web application stuff, obviously. One of our friends like to say cross-site scripting pays his bills, so I kind of like that little anecdote. And we do a lot of this black box stuff, so if you have a Java thick client or a natively coded thick client, a lot of these times these things don't use HTTP. They'll use some proprietary protocol the developers thought that they needed to make. And how do we assess these things if we can't use a burp or a paros or a PFI to get at that stream? So just to get a little bit more specific, during these assessments, like I've been alluding to, it's often the case that a developer will try to use something that's well known, HTTP. It's easy, people know about it, it's easily understandable, and it's easy to develop on. But the problem is they don't always need to use that. They can do their own thing. Also, there are a lot of competing algorithms out there, such as the remote procedure call for flash, like AMF, where it's not HTTP, it's something else. Proxies are trying to catch up to deal with that kind of information, but it's still not exactly there yet. And even if they do use HTTP, they might not be using it in a fashion that the RFC explicitly was written for. They might be doing something very interesting, and we have a pretty interesting example about that, which kind of highlights, oh, hey, we might need another tool that's not already out there.
So one of the things that we encountered was application. We first saw it sending traffic, and it looked, oh, it's HTTP, but it was a whole system for displaying, streaming video and things like that. And essentially, after the first request, all it was a bunch of a long-lived socket that just sent binary video data across the wire. And when you try and test that in something like Paros or Burp, and you have a lot of data flowing, and you have data that's not really interpretable as HTTP, it tends to break your proxies and not work, because it's not really HTTP. It's just something developers stuffed on top of HTTP, and that's a pretty common thing when mobile platforms provide HTTP libraries or what have you, but you don't really want to use HTTP as a developer. So we see that a lot.
So again, just to get really specific here, often isn't always. Developers don't need to use HTTP. They can do their own binary protocols. That gives us a hard time when we need to assess things. And there are Flash applications, ActiveX applications, where even if you're on a web app, again, you're not limited to only using HTTP, which means the security tester needs to not think that all I need to know how to use is an HTTP proxy. So let's go a little bit more specific on what are the annoying characteristics to an assessment that's kind of being done on an application that way. Well, if you're not using HTTP and if you're not using a well-known protocol, that means there's probably a tool out there that you can't use, or there's not a tool out there that you could use. That's the contrapositive thing. Anyways, so what that means is, okay, we need to roll our own client. We're going to need to write some special code. We're going to need to set up some special environment to get this information from the application under test or the device under test into our control and then back out to the server. That often means that we're writing very specific snippets of code with some general behavior, but there's specific information within the general behavior that's tailored for the application at hand right now. Then when the application assessment is over, we have to throw that code away. Then the next application comes and we have to do it all over again. And we're programmers at heart. We're lazy. We don't like to do that. Who likes to throw their code away that they work so hard on, right? So that's one of the main big annoyances of dealing with these kind of applications, that you need to do these one-off code examples. Also, another annoyance is if there is a proxy that kind of deals with what we need to do, often it doesn't do enough, or it does too much for us, and we need to kind of personalize it a little bit. But these proxies might be closed source, or they might be written in such a way that it's not friendly for a person to get in there and start putting in a plugin or messing with the behavior ever so slightly just to get our functionality that we want out of it. Another interesting example is, again, if it's not using HTTP, what is it? Like I've been saying from the beginning of the presentation, but it's the biggest motivator for us. If they're not using HTTP, if they're not using TCP, say they're using UDP over some random port, how are you going to be able to pause that traffic, edit it, and send it on? There's not very many tools out there that can accomplish this. We needed that kind of functionality. Also, say they are using some kind of well-known protocol such as SSL. We all know about SSL. We all know we can man-in-the-middle SSL. But what happens if they put a proprietary protocol within the SSL stream? Now all of a sudden you have some tool, man-in-the-middle SSL, gets the plain text, and has no idea what to do with it. Now you can't edit the tool and you can't do anything with that. And we recently came across an example with that, which highlights our first real-world use of Mallory. Jeremy can get into that a little bit more.
Right. So one of the things that we encountered was an application that was stuffing a bunch of TCP streams inside of an SSL stream. So, kind of like a VPN, but not exactly. Some remote display technology, essentially. And with Mallory, one of the first things we did was, tell it to man in the middle of this port as SSL traffic. It unwraps it, it sends it to our GUI, and we were able to, edit hex bytes and send it on its way and encounter interesting behavior in the application. And that's one of the itches we really wanted to scratch. We're going to talk about is generically solving this whole problem of sometimes you just want a simple TCP proxy, not a full-blown HTTP proxy or whatever. So that's a really good example of places where Mallory really helps us.
And Jeremy's been using Mallory for a long time, so I feel he kind of is spoiled and doesn't understand exactly how awesome one line that he just said. He was like, we told Mallory on a specific port, this is SSL. Now do all the magic that we've coded you to do with SSL already. That's it. It was like on a random port with all the functionality we've already implemented for SSL. Hey Mallory, that's SSL. Just do what you need to do, which is really awesome when you see how quick we can use that to start our assessment processes. But we'll get into that a little later. So why is this difficult? You don't have to believe me that it's difficult. I will explain to you why we believe it's difficult, because these are the processes that we have to go through every once in a while when we get these hard applications to assess. So the first thing we normally need to do on some application that we don't know the protocol and we don't know the ports and we don't know any of the other information is sniff it. We all know Wireshark. It's an invaluable tool to all of us as we do our assessments. We can pull the source port, we can pull the destination port, we can pull the IPs, the servers, any kind of buffer sizes that might need to be honored by mobile applications especially. Write that all down, save it, so that we can now start setting up our environment to perform our assessment. So after we get this information, we need to figure out a way, how do we break into that stream of data? So there's a number of ways that we all know that we can get into that stream of data. Some of them are more, I guess, developed for malicious purposes, and others might not be, but let's go over some pros and cons for these. So there's ARP spoofing. Essentially with ARP spoofing, you need to make sure that the client and the application supports gratuitous ARP. You need to make sure that the cache holds the information long enough such that it will send all the information to this man-in-the-middle gateway that we've ARP spoofed. Sometimes, though, these devices don't support gratuitous ARP. Sometimes the cache refreshes too quickly. We'll miss a packet or two, and then what happens is we don't get the full stream. And having a non-deterministic testing environment during an assessment can be vexing, to say the least. You will see things that you should see. You might not see things that you're expecting. That doesn't help you out when you're trying to assess an application. So ARP spoofing wasn't the way to go for us. There's DNS spoofing as well. Now what happens with DNS spoofing is we've come across a number of applications that, one, hard-coded IP addressing, or two, it's on an embedded device that we can't change the configured DNS server on. It's a closed device. You can't root it right away. We have a week for the assessment. We can't spend time to get at the bus and rewrite firmware to get at that. So we couldn't rely on DNS spoofing for our task. It was too specific, and it wasn't general enough for us to use it on every single assessment all the time. Well, there's a little bit more general way. After we do the research and we do the reconnaissance and we get all the destination networking information down, we can be IP tables ninjas, run information through our gateway that we control, and start redirecting traffic to the local host, our gateway, and hopefully to some interesting code that you're going to be running. Now the problem with this is I don't deal with IP tables every day. I don't want to memorize all this stuff, although it's not too difficult, but I don't need to. You don't need to. We're lazy again. We don't need to do these things if we don't have to. We want to be more efficient. So we kind of didn't want to deal with these one-off IP table rules per application based on varying ports and varying destinations. Like, we wanted this to be done automatically for us. But let's say somehow we were able to get into the stream of data. Now we're able to focus that stream of data into something that we control. What's the next step? Well, the next step is to spin up some listeners, spin up some forwarders, and make sure you have the communication. And when you have that communication, where you see that little pipe there, we would put code that we wrote, those one-off scripts that we were talking about, those one-off scripts that we throw away after every assessment because we don't need it anymore. We need to do something else. But again, if this